Welcome to our channel. In this video, we will talk about zeros of linear functions. We will look at what we mean by that, and we will look at some examples. So basically, zero of a linear function is a value of x that makes the function equal to zero. That means to find zero of a function, we need to find x such that f of x is zero. And it applies to any function, not just linear function. Let's quickly look at what we mean by this definition in terms of a graph. So if we have a function like this one, a linear function, so this is function f of x, this is x, this is y. Now we need to find the value of x when f of x is zero or when y is zero. Y is zero along the x-axis. So this line, x-axis, is the line y equals zero. So that value of x would be right here. So this is the zero of this particular linear function. Whatever this x value is the zero of this function. In other words, zero is simply an x-intercept. So zero of a function is basically an x-intercept. All right, let's look at some examples. So here we are given the function f of x equals 2x plus 10, and we want to find zero of this particular function. So all we need to do is set this function equal to zero. So 2x plus 10 equal to zero, and subtract 10 from both sides. We get 2x equals negative 10. Then divide both sides by 2. That gives us x equals negative 5. So negative 5 is the zero of this particular function. Because when you replace x with negative 5 in this function, that will make the function zero. Let's plot this zero in the graph. X equals negative 5 is right here. And if you want to graph this equation, we need one more point. When x is zero, f of x is 10. That point is somewhere up here. It's not on the given graph. So let's try to find what y value would be when x is negative 3. When x is negative 3, y would be 2 times negative 3, which is negative 6 plus 10. So 4. So the graph must go through this point over here. Then we can quickly draw the graph of this function. It must look like this. All right, so let's look at the next example. Here we have 6x minus 9, y equals 6x minus 9. So to find zero of this function, all we need to do is set this function equal to zero. So we just add 9 to both sides. Then on this side, we get 6x. On this side, we get 9. Our goal is to isolate x. We want to solve for x. So divide both sides by 6. That means x equals 9 by 6. And we can simplify this 9 by 6. So we get x equals, if you divide top and bottom by 3, we get 3 by 2. So this is the zero of this particular function. So 3 by 2, 1.5 is somewhere over here, 3/2. So the graph must go through that point. And to be able to graph this function, we need one more point. So for example, we can take x equals 2. When x is 2, we have 6 times 2 minus 9. 12 minus 9, which is 3. So the graph must go through that point. So the graph of this function will be a straight line going through those 2 points. Something like this one. And of course, it should extend on both sides. So this is the graph of this given function. We are done with this example. Let's look at the next one here. So we have f of x equals 2x by 3 plus 8 by 7. Again, we want to find zero of this function. All we need to do is set the function equal to 0. plus 8 by 7 equal to 0. There are different ways of isolating x. We can move this constant part to the other side. Basically subtract 8 by 7 from both sides. So that will give us 2x by 3 equals negative 8 by 7. And then we can cross multiply. So 2x times 7 is 14. We get 14x equals 3 times negative 8 is negative 24. And then finally, you can divide both sides by 14. So we get x equals negative 24 by 14, which is, if you divide top and bottom by 2, you get negative 12 by 7. So this is 0 of this particular function, negative 12 by 7. So negative 12 by 7 is somewhere over here between negative 1 and 2. And we need one more point to be able to graph this function. When x is 0, y will be simply 8 over 7 because that part becomes 0. So when x is 0, y is 8 over 7. 8 over 7 is little over 1, somewhere over here. So the graph of this function must go through those 2 points. So I believe the graph will look like that one. And of course, it should extend on both sides. So this is the graph of this function. All right, so we are done with this example. This is the next example we have. Again, we want to find 0 of this function. For that, we simply set this function equal to 0. So we can subtract 7 from both sides. That will give us negative 2x equals negative 7. And then we can divide both sides by negative 2 because we want to isolate x, negative 2. So we get x equals 7 by 2. So this is the 0 of this given function. So 7 by 2 is 3.5, which is over here. And we need one more point to be able to graph this function. So when x is 0, y is 7, I assume 7 will be somewhere over here. So we can just connect those 2 points to graph this function. So the graph of this function should look something like this one, using the zeros. All right, we are done with this example. And this is all I have put together in this video. Thank you for watching. See you in our next video.